Okay, hello everyone. I think last time we discussed the area for polar system. Wait, sorry. Okay, so the what you need to remember for the polar system is you need to remember the formula for sector. Okay, for sector. Okay, sector is like when you have a circle and you slice the circle like a pizza. Okay, the sector is the slice of pizza. Okay? And with this formula, you can evaluate the area. Okay, depends on the angle. Okay, depends on the angle. I think we already have several. I think one example here. This is the cardioid. Uh, the cardioid 1 plus sine, okay, 1 plus sine theta. So cardioid is happen when this is 1, this is also 1, the same. So you will have the cardioid. If this is 1, this is 2, it will be having a loop. Okay. I think you need to check that out. Okay. What's the difference when you place something here? But I think later, if we have time, I will show you, or maybe I will attach to the model some link. Actually, it's a graphing calculator, Desmos, but I already make the polar and line. So you just change the variables, and then you can see how the graphs look like. But later, I will show you. So the question is, you have the cardioid, okay? This blue, the blue color. You have the circle. You need to find the area in the red area here. If you think in xy, probably you remember that if you integrate something, you are subtracting the green and the blue one, right? If you have the equations, that's it's in xy. But in polar, it will systematically different. Okay, so what you need to do is you need to think like a counterclockwise system. Okay, like a clock, but it's counterclock. So you start from the angle 0, and then as the angle increasing, the point will be point out at different point, and it turns out making a curve, and that is the polar curve. So what we need to do is, because we need to find exactly at this area, we need to find at least what is this point and what is this point, and we get some theta here after we equaling the system, the equations, and then what we are going to do is we plug into the formula, okay? And this is the circle, the big one here. So the circle from this angle until here, but because it's symmetrical, we can just making up till here, and then you can multiply by 2, or if you want, you can directly go to 5/6 if you want to calculate, and then minus the cardioid. The cardioid is here, right? The blue one. So minus from here until here. Okay. And we already solved that. We already find the solutions. And using some basic integrations method, and we get from here the sine squared. We can use the double angle formula, and then you get the cosine 2 theta, and finish that with the results after you plug in the value, and you get its pi. Okay. Now I will show you another example, and then we can move on to the arc length. Okay, this is another example. Okay, can you try? The question is find the area. Okay, the purple area. Okay. So maybe I will write the general formula at the top. But the general formula for the area is integration and maybe, yeah, you can say this is alpha beta. Okay. Now you have the inner loop here. Okay. Like I said before, this is smaller than this one, right? That's why you have the smaller loop. And anyway, this is 1, this is 3. You know how? Why? This is -3, -1. Okay. So it's from if you plug in the theta when sine is maximum and when sine is minimum, you will get that number. Okay. But anyway, you can see as this number 2 minus 1 is 1. Okay, the distance is 1. 1 plus 2 is 3. And every limmason has the same pattern. Okay. But the difference is maybe this one has a loop, the other one just a cardioid, and maybe the other one is just a small curve. And for this case, I think you don't need to finish until the exact answer. You can stop until you integrate, you find equation, you can stop there. No need to plug in the angle. The first thing to do, what you need to find. You need to find at least when the radius is 0, right? You need to find the radius is when it's the radius is 0. Let me write maybe some notes here. So radius, or maybe not radius, maybe the pole is reached when r is 0, right? It means the polar axis. The pole means the polar axis. So r is 0 when we can equaling the equations now. Equaling the equations. So we will have sine theta is how? So you get several theta, right? And we can use this theta in our integrations. Okay. So at the end, we need to calculate the big one, and then we have the -1 here. And remember, this is also have movement from here and going here, going here. Mm-hmm. Okay, now the theta is, the first is 5/6, right? 5/6. The other one is 5/6 pi, and then 13/6 pi plus the whole circle, right? Okay. Now we are seeing the outer loop and inner loop. Let me write here. So this is maybe this is when theta is 5/6, right? It means from 5/6, and then we move until maybe I will write all of them here. And then it's also have the other 2 pi, right? It's a circle, right? It's the angle. Okay. Now from here, wait, means 5/6. Sorry. So it means if we look at from 5/6, we are tracing all until 13/6. We get the outer loop, right? And if we are looking from here, from 5/6, and we go to 5/6, we get the inner loop. So outer loop minus inner loop. Okay, and you need to think like in polar. Okay, so we need to move away from the xy. So let me write the equations. So equations will be area. Let me write the outer loop minus inner loop. So area is integrations. The outer loop is from 5/6 pi, and then 13/6 pi. And then half, what is the equation? So 1 minus 2 sine theta squared, and then d theta, and then minus from 5/6 to 5/, and same thing here. I think this can be solved, not too difficult, right? You need just to expand the formula, right? And then use the double angle. It's quite trivial process, but it's not a tricky one, right? It's not a tricky one. But it's a long equation. Do you want to write this one? Okay. Or anyway, if in the exam, when you write maybe too long, maybe you can write one by one. Like you can write inner loop, calculate, outer loop, calculate, and then outer loop minus inner loop. That's also okay. Okay. And then the next step, we need to solve the sine squared here with the double angle formula. Mm, all right, 2, and then half of the 1 minus cos 2 theta, the double angle formula. And then same thing here. Okay, now we can integrate so half plus 1 is 3 over 2, with 3 over 2 theta. And then it will be plus 2 cosine theta. And the other one is minus half. Sine 2 theta, right? And this is start from 5.65. And this will be 3 over 2 theta plus 2 cos theta and minus half sine. Yeah, address, you can just plug in the angle, and yeah, it will be very long. But let me just write the solution. Solution is 5 plus 3 after some, wait. So after some process. Okay, I think we can go on, and if we still have time, I will give maybe another example for you, maybe at the end of our course today. Okay, any questions first? Any questions first? Do you still have confusion how to find the angle? How to find the angle? Okay. So you need to think like counterclockwise, okay? Because this is the key in all the polar calculus. Okay? If you still haven't figured out how to find the angle, then it will be very hard, because this is essential in polar. Okay, okay, I will go to the next sections. So the next section is the arc length in polar. Okay. arc length is polar. Remember that from relations between the xy and the polar, we can have x equal r cos theta, y is r sine theta, and for r is function of theta, we can write x functions of theta cosine theta, and y function of theta sine theta. Okay. Okay. To find arc length or length of polar curve. And then the theta is from A to B. We start from, let's see the form of the first derivative of dx over d theta. So it will be dr over d theta, okay, and then cos theta, and then minus r sine theta, okay, the product rule, okay. Or maybe I will write the x equal r cos theta, and then you have the product rule, right? Okay. And then y is r sine theta, and same thing here. We get dr over d theta plus r cos theta. And then the arc length, we need to get the value of, remember the arc length? At least we need to have this value. Right? Let's just calculate this value first. So meaning we need to square this, also square this, right? Okay. So the first one is dr d theta squared and then cos squared theta. Okay. And then the other one is 2r dr d theta sine theta cos theta. And then plus r squared sine squared theta. And then plus the dy over d theta squared is dr over d theta squared sine squared, and then plus 2r dr over d theta sine theta cos theta. And then plus r squared cos squared theta. Yeah, we have long equations here. But this one can be canceled with this one, right? Okay. And then we can simplify and grouping all the components. So the first is this component is cos squared theta. and then plus sine squared theta, and then plus r squared is sine squared theta plus cos squared theta. Okay, so this equal 1. This is equal 1. So we can simplify this form into plus r squared and then square root. Okay. Oh yeah, I forgot the square root here. Or maybe no need. Maybe I will just erase this one. Okay. So we get this. Okay. Now the arc length becomes okay. It's become simple formula for arc length in the polar. Okay. Okay. Any questions? Okay. So the arc length we can simplify with this formula: r squared plus dr over d theta, the first derivative and the squared. Okay. Now I think we can move to the next one. We can move to tangents. So tangents. And we first define the relations, like the arc length. And then we use the product rule to find the first derivative. Okay. Now the tangents is defined by dy over dx. Okay, this is the tangents. Okay, so the tangents. Uh, this case here, I'm not suggesting to blindly memorize this. Okay, uh, I think you can just remember the relations. The x is r cosine theta and y is r sine theta, and then you need to differentiate using the product rule, and you will find this two. Okay, I believe that is the better way to approach if you maybe forget. Okay, if you try to blindly memorize this, not good for your health. uh, is it tangents? And another way, like in the previous courses, we will also, in some cases, we will observe the horizontal and the vertical tangents, and by doing so, actually, it's kind of makes sense on how we locate the horizontal or vertical tangent. Basically the same thing, but it's in the r theta. Okay. So horizontal tangent is we find the dy over the theta is 0, and provided the it's not 0, so we still have 0 over some constant, right? If we have 0 over 0, then we cannot solve that problem. And the vertical tangent, we will get this when 0 and the dy over the theta is not 0. So basically, it was saying that, or let me write horizontals like this, vertical like this, right? Okay. So anyway, what does it mean is we will have the gradient is 0, meaning we need to find dy over dx is 0. 0 can be obtained when dy over d theta is 0, and the bottom part is not 0. So we will get dy over dx 0. Okay, and the vertical tangent is going up, right? So in the terms of gradient, it is actually undefined. It will have infinite. So we will say that in the statement, dy over dx will be undefined when dy over d theta is some number, and then the bottom one, dx over d theta is 0. So anything defined by 0 will become undefined, and that is actually what the gradient, vertical gradients meaning. Okay. Okay. I will give you some example from here. I will give you the other example, and I will show you, because in your textbook there is no mentioning about the surface area for the polar. I will show you how to find that. Okay, let's go to the example. Uh, example. Uh, you have the cardioid 1 plus sine theta. Find the slope of the tangent line when theta equal pi/3. And then another question is find the points where the tangents are horizontal or vertical. Okay, the question is, you have the polar curve, cardioid 1 plus sine theta. Find the tangent line. You have the theta equal pi/3. Find the points where the tangents are horizontal or vertical. Wait. Did someone connect to my screen? Wait a moment until he realized that, oh, I'm connecting to someone else. He tried to connect to the his screen, maybe the other class. It is the other professor. He make mistake. Okay. Yes. Huh? Yeah. Yeah. You can look here if you want to. Yeah. I think he just realized. Oh, what is happening? Because he's connecting to my laptop. Okay. Okay. He realized. Wait. Okay. Okay. Yeah. Find the slope of the tangent line. Actually, this is the example from your textbook. If you have the textbook, you can look up the example 5. So anyway, the slope of tangent line means, like in the previous calculus 1, like the last semester, the slope of tangent lines means we need to find dy over dx. And we can write down the previous formula. Now what we need to do is we need to just substitute d over d theta with the equations. R is 1 plus sine, and then we need to derive 1 plus sine. Well, let me write here why he connect again. Okay. Wait. So let me write dr over d theta here. From these equations will be cos theta, right? Okay. So this will be cos theta sine theta plus r is 1 plus sine. And then this will be cos theta. Let me just write cos theta, like just like in your textbook to help you. Okay. And then solve this. 1 plus 2 sine, right? And then the bottom one, we will have cos squared let me write here. It can be cos squared theta. You can write this cos 2 theta minus 1, or as your textbook, you can write this as 1 minus 2 sine squared theta minus sine theta. Anyway, you can calculate any method, any steps you want. But the end is just plug in the theta. Maybe this is just for helping calculate the number. And plug in x, oh wait, yx, theta equal pi over 3. So it goes to cosine pi over 3, sine pi over 3, half, 1 plus square root of 3, 1 plus Square root of 3/2. And it will be 1. We can solve this 2, right? And then it will be 2 plus square root of 3, and the result is -1. Okay. Okay, I think for the calculation, it's not too concerning. Okay, as long as you get the idea for the tangents, and then for the horizontal and vertical, we need to have this equals 0 and this equals 0. We need to find these two relations. So dy over d theta is cos theta, and then 1 plus 2 sine theta. To find 0. So we can find theta from here. Of course, it's pi over 2 and 3 over 2 pi. And how about the other one? We need to find when the sign is negative and when it's plus 1 is 0, right? So the sign or the theta here is 7/6 pi. Okay. The 7/6 and 11/6 is when the sign will be negative, right? So negative half, so -1 plus 1 is 0, right? So either from here, cos theta is 0, or maybe if you're confused, let me write here. So we need to solve this 2. So we have 2 equations. Okay. And then the other one is the x over d theta. So at least we find the point first. We find the point first. Okay. And we find the x over d theta. This should be 0. And this means we have 1 plus sine. That should be 0. Or in this case, it's -1, right? And the other one is 1 minus 2. So we find also the negative number here, right? The negative half, right? So that is when the theta is 3/2 pi from the sign is negative, right? And 5/6. Okay. Okay, we get all the theta here. Now we can at least sketch the curve to see how it looks like. So we have 1 plus sine theta. Let me make a little bigger. Okay. Now, based on what we have done for the polar, for the cardioid, this will be 1. Wait. This is 1, 2. So this is 2. This is 1. This is 1. So this is the coordinate. Yeah, more or less like a heart or maybe a fruit, right? Okay. Now this is the horizontal, another horizontal here, another horizontal here, vertical here, vertical here. Okay. Now the important thing here, the books in your textbook, it's mentioning that it will have the vertical tangent here. And this can be approached by using limit. Okay, let me just make the point first. Okay, so the point here is 2 pi over 2. And the point here is 3 over 2 pi over 6. And the point here is half point here is half okay. So in your textbook, you can, if you read the arguments, let me write, okay, when theta is 3 over 2 pi, okay, you can see the dy over d theta is 0 and dx over d theta is also 0. So this is 0 over 0 situations, okay. So when you have 0 over 0 situations, you need to think to approach using limit, okay. So limit, let's approach theta from, you can approach from left, from right, depends on case, but sometimes both are okay. You can write 3 pi over 2. Let me write with minus like that one, meaning we approach the theta from the left, okay? So we approach the theta approaching 3 over 2 pi from the left, okay? And this way, we can approach the tangent. And let me write the equations like this. And also this one. Or maybe I will write another limit here. Limit, same limit. Okay, so to solve this, we can use the L'Hopital rule, okay, because it's 0 over 0 situations. We can use L'Hopital rule. So it becomes 1 over 3. And then we still have cos theta, 1 plus sine theta. And then still have 1/3. We do a L'Hopital rule. And cos become negative sine. And sine is cos theta. In which we end up with the infinite. So we can say that limit as theta approaching 3/2 pi from the left is approaching infinity, and theta approaching from the right is negative infinity. Okay. So because of symmetry. So because of that, because of this undefined, because dy/dx undefined, then at 0, 3/2 pi, there is a vertical tangent. Okay. Okay. So whenever you find any tangent, and when you define dy/dx as dy/d over dx over d theta, when you have dy/d theta 0, dx/d theta 0, you can approach both of them using limit, okay, and then use the L'Hopital rule, okay. But in normal case, what you need to do is finding dy/d theta 0 when you want to find the horizontal, or dx/d theta 0 when you find the vertical tangent, and the other element will be a number. Okay. Okay. Now I will give you the one one notes. Okay, before ending this chapter. I think in your textbook, exercise number 75, I will write here the content of the exercise. Okay. Or maybe any questions first? Is there any questions? Okay. So basically, what we did here is we solve using limit. Okay, using limit. Okay. Next thing, the area of surface. We give notes here. Exercise number 75. So if you have the so the question is, what is the area of surface in terms of polar? Okay, so you have the r is function of theta, and theta is from A to B. The functions, the f prime is continuous, and probably you can write this as the restrictions. So AB is in between 0 and pi. Okay. So you get the idea? in parametric, you have restrictions for area of surface. You only have, or you only can traverse once, so you cannot go back. Because if you go back when you rotate, you'll be having a weird area, right? But here, what does it mean? 0 and pi means okay. Let's say this is the polar axis. Okay, so this is when the theta equals 0. Okay, this is theta equal pi over 2. This is theta equal pi. So what this restriction means is you only have the A, let's say A here until B here, is in between 0 and pi. So when you have like that, and you need to find the area of surface, rotate here, you can easily imagine the area, okay? But if your restrictions is greater than pi, you will be difficult how to rotate, right? Unless maybe rotate to maybe this line. Yeah. But anyway, for this case, in your textbook, the exercise that it has the restriction. So that's the logic. So that's how we can calculate the surface area. Now rotate it. Okay, it's rotated about the polar axis. So the polar axis is the baseline. We call it the polar axis. So with every time you read the questions and it said the polar axis, means the polar axis here. Okay. So in polar, okay, actually this line is not necessary in polar. This line is polar axis. So what you need to do is start from here, going here, and depends on the polar equations. You will have certain line or curve, right? Okay. Okay. Now let me write the general formula for surface area. General formula in parametric. Okay. We already did this before. So as, let me write this, rotate it about x-axis. This is to start on how to find the area of surface in polar. So write 2 pi y, maybe from A to B, and then the arc length is the x over the, let's say d theta for the parametric is theta plus dy over d theta, and then d theta. Okay. Okay, this is the general formula, and then remember from x, y, we can convert to r theta. Okay. So theta is here, r, and then this is x, y, or I will write r cos theta, and y is r sine theta. Okay. Now through the polar, okay, through calculus in polar, we get dy over d theta is dr over d theta sine plus r cosine theta, and then dx over d theta. Wait. Dr over d theta cos theta minus r sine theta. Okay. And we already did this, that the basically we already did the calculation, so I will just write the important point. Okay, so we can write the S is 2 pi, y is r sine theta, square root of r squared plus okay. Now in exercise this in the exercise, the number B say that use this formula to find the surface area generated by rotating the lemniscate r squared equal cosine theta about the polar axis. So you have the r squared is cos theta. So this is the example. Rotated about polar axis. So we can, or maybe we can draw first the picture. So lemniscate, we can, because it's cosine, then when it's 0, it's having the maximum point, right? So we can start from here, and then this will be right here. Okay. Let's say this is the 2 and 0, and this is 0 and cos pi over 4, right? Pi over 4. Now we need to find the surface area, right? So we can find, actually because it's symmetrical, we can find the surface area if we are plot or see this from 0 until pi over 4. We can rotate, right? And we can multiply by 2, and then we can have 2. Okay, so we can use this formula, multiply by 2, and then using 0 to pi over 4, and r is this lemniscate. We can solve the equations, and later we can calculate the surface area. Okay. So let's write r squared is cos 2 theta. So we can use the implicit differentiation. And then this will be negative 2 sine 2 theta. And dr over d theta will be negative sine over r. And we can square this. Okay, square this. and then sine squared 2 theta over r squared. Okay. Now the r squared is our original equation, so we're going to use this to change the formula. Okay, now we can use the equations. I will go here. So S is 2 from 0 to pi over 4, 2 pi. And then the r sine theta, the r is square root of cos 2 theta, okay? And then sine theta. And then square root of r squared is cos 2 theta. And plus this result here. So plus sine squared 2 theta over cos 2 theta. And then d theta, okay? Okay, now we need to solve this. Okay, let me solve this 0 pi over 4. Let me just write this is still sine. And the inside square root will be cos 2 theta. And this will be cos squared. And then plus sine squared. And then d theta. This whole thing become 1. And this cos 2 theta can be cancelled with this one. Okay. So we only have 4 pi sine theta d theta. And we can integrate this. Plug in 0 pi over 4. Minus 4 pi square root of 2, right? Or this will be 2 pi 2. And this is the calculations result. Okay, any questions? I will show you some parts for some graphs actually, and how to use the graphs. I will attach the link in the Moodle later. So let me close this for a while. Okay, this is using the Desmos. Okay. Oh, wait. I need to check the recording first. Wait. Okay. Okay, I think this is good for you to learn and maybe see directly the shape. Okay. So this is maybe it's too small, but it's 3 minus 3 cosine theta. So you can actually change all the r if you want, but this is already in r equal 1, r equal 2, r equal 3. Okay, so it's a polar grid, and this red line is the polar curves, and this is 3 minus 3 cosine theta. So let's change to other. For example, let's change to 4. So it will have exactly here loop. The distance is 1, and the distance here is 3 plus 4. It's negative 7 here. It's 7. Okay. Or maybe we can, this is a circle. Um, maybe we can have like that. Or maybe multiply by 5 to make it bigger. So this is the rose curve. Okay. You have the 5 cosine 4 theta. Okay. 5 cosine 4 theta means 4 theta means it will have eight leaves. Okay. And if you maybe let's make 3 and then 1 plus, you can also have like this one. So this is combinations. Okay. Combinations, the limazone and the roses. Okay. But it still have a unique pattern. What you see here, this is 1 plus 3 cos 4 theta. Okay. So you will have, okay, based on the equations, you will have 8 petals, the 4 big petals and 4 small leaves. Okay. And 1 plus 3, the maximum is 4. So the big one is having 4. And the small one is having 2. Okay. From the gap between 1 and 3. Okay. I will attach this link to your model system, and you can play with this thing. Okay. I just found and someone made online, and then okay, I'm just using it for the exercise. So all the exercise when you need to like, if the question not having any picture, maybe you have trouble to draw the picture, you can use this to exercise in exercise and see the pattern yourself. And I think it's pretty useful. Okay. So that's the Desmos. And if I change this, okay, it will be the different if this is 4 minus. Okay. It's become, yeah. Okay, I think that is for the Desmos, and I think we could just close this. And back to here. Now, in chapter 10, actually, I will not go to conic sections and like the last two parts, conic section and conic section and polar coordinates. I think I will skip them for a while. I will go directly to chapter 11. Okay. And I think I will just do a little bit intro for today, maybe around 5 minutes, and then we can finish for today. Okay. So we finished chapter 10. Um, every time we finish a chapter, or maybe two chapters, we will have a quiz. So I'm planning to having the first quiz for only chapter 10, and the next quiz will be after 11 and 12. So yeah, maybe chapter 10 we will have a quiz, but maybe not next week. Maybe not next week. Maybe so from to, from now on and until next week, I will give like chapter 11 and maybe some review of chapter 10, and then we will have a quiz. Okay. So maybe what the time it is for. So maybe 18, 18, or maybe not 18. 2, 9, 16, 16. The Tuesday, 16. Okay, 16 quiz one. Okay, so chapter 10 from the calculus in parametric and calculus in polar. Okay, so maybe 16. So 3, 16 quiz one. Okay. Okay. So from now on and next week, I will focus on the chapter 11, maybe half of chapter 11. So 11.1, we will have a sequences. So chapter 11, we will discuss sequence, series, and power series. So I think I've told you before the Zeno paradoxes. Let me write the Zeno paradox. Okay. The Zeno paradox is telling you. So when you are walking, like for this, let's say you walk, the distance is 1 meter. Okay. The Zeno paradox is telling you that you can walk this 1 meter half, and after half, you need to walk half of that half. And every time you start to walk, that rules is applied. So first you are walking half meters. So maybe until here. So this is half, okay? And then after this half, you can only walk half of halves before, right? So here, so this will be 1/4. And every time you are walking half of that. So in any way, can you reach the wall? If we think in this number, okay, we will never reach the wall, right? We will never reach the wall. But if we are looking at the real thing that we can observe, not in a number, we can use the limit approach. And we will just saying that, okay, it's just 1 meter. Okay, he walks 1 meter. But actually, maybe he walks 0.9999 maybe. Okay, but in limit, because we are already discussed limit a long time ago, that limit saying that it stated that we can ignore really small parts of that number, and we can just say, okay, it's 1 meter. Okay, so this is the Zeno paradoxes. So let me write all the distance of the man walks. It's half, and then 1/4, 1/8, 1/16, right? 1/32, etc. And this. Okay. And from this scenario, from this paradoxes, we know that we will have something called infinite sequence. So the sequence or infinite sequence is a list of numbers. Written in order. Like from A1, A2, A3, until some n. Okay. And we can write this as, if you remember, we can write this as an. Or if you want to write completely, we can write this from n equal 1 until infinite n. But I think usually we are more familiar with the left one, right? We just keep the left one. The right one, it's not really common use. And because of we can arrange the numbers by our own rules, right? If we can have rules for each numbers, we can write many sequences. Okay, so the first idea is in sequence is finding the formula. The formula for general term. The example cases is we have 3/5. Okay. So we start from 3, and then 3/5, negative 4/25, 5/125, negative 6/625, 7/3125, and so on and so forth. Okay. So to find the general term, okay, if you see any positive, negative, positive, negative, positive, it's called the alternate sequence, in which you can apply the -1, and depends on the n. You can say n or n-1, depends when it became negative or positive, right? And then we can solve the other one with 3/5, and just looking at the, for example, 3/5, we can see the top and the bottom. Okay. At the bottom, 5 become 25, become 125, and then so on and so on. It's stated the 5 squared, right? And the top one is just 3, 4, 5, 6, 7, but it's not starting with 1, so it's n minus something, right? Or n plus something, n plus 2, okay? So when n is 1, plus 2 is 3, 4, it's on the formula, right? So we can uh, generate the general terms, okay? So the general terms will be an is -1, n minus 1, and then n plus 2, 5 squared. Okay, this is just an example like what you did, I think, in high school. High school, right? Okay, yeah, in high school. So yeah, if you have alternate sequence, use the -1 here. And depends on when the positive or negative comes out on the terms. You can use n minus 1 or n. It depends. Okay. Like for example, if you start from the very beginning, like negative, then you need to change this, right? And the other one is if you have the fractions, you can solve one by one. Okay, you can look the first top one first, and the second is the bottom one, the denominator. Okay, and you can find easily here, I think. And I think you can check the textbook to the very beginning. Okay, that's just the intro. After this, we will go to the limit of the sequence, like what we have in the Zeno paradoxes in detail. Okay, so that's the sequence. I hope you still remember how the sequence or the series looks like. Okay, so I think we will finish the class today. Okay, I will finish up until here. Any questions? Okay. So the first quiz next 2 weeks. Okay, next 2 weeks on Tuesday.